WAN is abbreviation for Wide Area Network. WAN is a network that covers a broad area like cities or even countries and used to connect end devices in local area network like computers and printers which are distributed across large geographical areas. In simple words, we may say that WAN is used to connect more than one LAN. The biggest WAN network in the world is Internet. In fact, we may call Internet as a super WAN. WAN service works at layer 1 and layer 2 of OSI model. Layer 1 is the physical layer and relates to sending bits and bytes across devices in form of electrical, radio or optical signals through a transmission medium. Layer 1 defines physical characteristics like interface types, pin layout and voltages. There may be different types of interfaces like V.35, X.21 and others. Layer 2 is the data link layer of OSI model and sits above the physical layer. This layer is responsible for handling errors in physical layer. Further, data link layer is divided into two parts which are MAC and LLC, where MAC stands for Media Access Control and LLC stands for Logical Link Control. Some of the WAN link types in data link layer are frame relay, ATM, and X.25. Different types of WAN topologies are available for connecting multiple locations or LAN environments. Each type of WAN topology has its own pros and cons in terms of performance, cost, and scalability. Let's understand these topology types in detail. Point-to-point is the basic and simplest form of WAN topology involving dedicated leased line connection like T1 or even line. Only two devices are involved in a point-to-point connection. A point-to-point connection is transparent to the customer as if there was a direct physical link between two ends. Point-to-point topology is favorable choice when communication is required between two sites only. However, problem occurs when multiple sites need to be connected and provisioning a point-to-point connection across each site will incur high cost due to multiple dedicated number of links. In hub and spoke setup, sites are categorized into two types, that is hub site and spoke site. The central site is called a hub and branch site is called spoke. Communication between two spokes always happens through the hub. As shown in the diagram, for site A to communicate with site B, traffic will first go to the hub site from site A and then directed towards site B from hub site. Such a setup is preferred when organization requires control of site-to-site communication at hub site. However, there is a trade-off because communication across any two spoke sites incurs additional delay as it needs to travel through hub site. In full mesh topology, each node is interconnected to each other. This is unlike hub and spoke topology where all the communication has to go through the hub. As shown in the diagram, traffic for site A to site B communication will directly flow through service provider across each other and will not traverse via hub site. The associated cost with full mesh topology becomes very high. This slide shares major type of devices in a WAN environment. Router is to interconnect LAN and WAN or different WAN segments. Further, router contain ports which are used to terminate WAN service provider links like serial ports. In some scenarios, we may also need to deploy CSU, DSU or even modem for terminating service provider links. A WAN switch is an interconnecting device which works on layer 2 of OSI model and is used in service provider networks for switching traffic in various technologies like frame relay, ATM or even X.25. These are different from network switches we use in our environment for connecting LAN devices like computers and printers. The key function of modem is to perform modulation and demodulation of signal. Analog carrier signal is encoded to digital information and then same is demodulated at the other end to decode the transmitted information. Communication server concentrates dial-in and dial-out user communications. A COM server may also have a mixture of analog and digital interfaces and support hundreds of simultaneous multiple users. WAN connection can be in many forms. This categorization will be shown through a flowchart. There are two main types of WAN connections: dedicated connection and switched connection. Dedicated connection involves a point-to-point lease connection which may be T1E1, T3E3 or even DSL connection. Under switched connection, we may have circuit switched or packet switched links. While POTS and ISDN are examples of circuit switched link types, on the other hand, MPLS, X.25, frame relay, and ATM are types of packet switched connections. Leased link refer to pre-established connection between two customer locations through the WAN service provider network. This type of circuit are dedicated and do not need to be established before data transmission. These are generally bidirectional and symmetric communication circuits which are very high on cost. They provide high bandwidth and constant data rate for data transfer. DSL is abbreviation for Digital Subscriber Line. There are many flavors of DSL, namely ADSL, SDSL and VDSL among others. ADSL is the most commonly talked about flavor which provides both internet and voice services through a single two-wire pair of telephone line. ADSL technology employs DSL router or modem and splitter at customer premise and DSLAM at the provider end. The DSLAM at provider end is used to multiplex multiple customer DSL connections, while a splitter at customer premise separates voice and data signal. The data signal is further terminated on ADSL router or modem, which further provides internet service to end devices by converting DSL signal into Ethernet signal. ISDN is abbreviation for Integrated Services Digital Network. ISDN is a circuit switch technology which carries digital signals including voice, video and data over PSTN links. ISDN can be categorized into two parts, BRI and PRI, where BRI stands for Basic Rate Interface and PRI stands for Primary Rate Interface. ISDN BRI is recommended for small office and homes and includes two bearer channels of 64 kbps each and one D channel of 16 kbps. This computes to 144 kbps, out of which 128 kbps is the actual data traffic. ISDN PRI is preferred for large offices and establishments. PRI can be further divided into two flavors, T1 PRI and E1 PRI. T1 PRI is North American standard and includes 23 B channels and 1 D channel, which includes total bitrate of 1.544 Mbps. E1 PRI is European, Japanese and Australian standard, which includes 30 B channels and 1 D channel, adding up to form 2.048 Mbps of bitrate. ISDN BRI can be connected to customer network through various means. In this example, a terminal adapter is provisioned to terminate ISDN BRI connection at one site, while ISDN router with U or ST interface directly terminates the ISDN line. X.25 is a packet switching WAN technology. X.25 network devices fall in three common categories: PSE, that is Packet Switching Exchange, DCE, that is Data Circuit Terminating Equipment, and DTE, that is Data Terminal Equipment. Notable is that packet switching exchanges constitute the majority of network. It transfers data from one DTE to another through the X.25 network. Frame relay is successor of X.25 protocol. Frame relay is packet switching technology which performs end-to-end error correction. The virtual circuits in frame relay are called as DLCI. Some of the key reasons which make frame relay preferred choice were its ability to support higher data rates, that it's less expensive and has lower overheads. ATM is abbreviation for asynchronous transfer mode technology. ATM is capable of transferring voice, video and data over provider network across locations. It is built on cell-based architecture and ATM cells are always of fixed length of 53 bytes. The ATM cell contains a 5-byte ATM header followed by 48 bytes of ATM payload. ATM technology is very scalable and can support data rates even faster than OC12, that is above 622 Mbps. MPLS stands for Multi-Protocol Label Switching. It is a multi-protocol WAN technology and based on path labels rather than IP network addresses. MPLS technology works in layer 2.5, that is between data link and network link layer. Two types of routers in MPLS are LER and LSR. LER is abbreviation for label edge router and operates at edge of MPLS network. LER is responsible for attaching label to incoming packet or removing label from outgoing packet at edge before forwarding to IP network. LSR is abbreviation for label switching router and lies along the path of label switched path established by LERs. The LSR removes the incoming label and replaces it with a new label. The benefit of MPLS are scalability, performance, reduced network congestion, and a better end user experience.